Hello, everybody, and welcome to WOW Live, Word on Wednesdays Live. It's great you could join with us this evening. It's great to have you listening in, watching. We are continuing a topical study we began 2 weeks ago, which the Word of God speaks authoritatively of, and which, as well as foundationally, it's the subject of origins, how everything began. And the last time we were together was on September the 15th. For the most part, we looked at that point into the age of the earth. The modern opinion is that the earth is 4.5 billion years old. I wouldn't have put it over a day over 3 billion. It looks pretty young to me. We sought to find out how this idea of vast ages came about. Where did this come from? Was there some absolutely stellar scientific discovery which conclusively demonstrated beyond all doubt that the Earth is billions of years old? Nobody could argue otherwise. Well, no, not really. We found out that nearly 200 years ago, during a historical period known as the Age of Reason, and by the way, Papa Smurf was not part of that. The only reason he's in the picture is he's wearing a Phrygian cap, or sometimes called a Liberty cap, which is the same as the goddess of reason there, holding the spear. I guess if he acts up, she's got him or something. I don't know. Anyway, the Age of Reason, there was this growing movement among an intellectual elite of Western Europe who sought to discard the ideas of God and the Bible and to place the reason of man on the throne. They wanted to divorce the creation from its creator. It came out of this age of reason thinking, enlightenment thinking, sometimes it's known as. This meant that they had to come up with some kind of alternative explanation for the existence of everything. You've just eliminated a creator. Now you've got to explain, well then, how did everything get here? That's one of the key questions. Where did we come from? That philosophy asks. And so now they've got to come up with some kind of answer. And one of the first notions that they came up with was, well, if everything arose into existence apart from any kind of creator being involved, all by itself, by some heretofore unknown process, well then, whatever that process might be, it was going to take a long time for it to happen, all right? So time becomes a very important factor in this whole thing. Whatever we suggest, it's not something that happened quickly. It didn't happen in 6 24-hour days, okay? It took place, had to have taken place over a long period of time, gradually developing. That kind of thinking began to come up. And so the idea of long ages comes out of that. It grows out of that need for long period of time because we've just done away with someone who can create by the power of his word. We've removed him from the equation. Now, it's impossible. This is the issue. It is impossible for the discipline of science to scientifically and accurately deal with this question of origins. And that's because one of the key components of the scientific method is to be able to actually observe the phenomena which you hope to explain. We had the scientific method chart up last time, and observation is right at the top of the list. That's the first thing that happens. A phenomenon is observed. And we have a question now, and we want to explain how that phenomenon, or something about it anyway. And if something is unobservable, such as the origin of life, let's say, or the origin of the earth, or the beginning of the universe itself, all those things are outside of our purview, well then it falls outside of the parameters of observational scientific investigation. So our first step in the scientific method is meaningless. It doesn't exist. What you're left with then is speculation and assumption about what happened. You have to assume certain things to be true in order to try to examine historical events and the supposed processes which occur during those events. You must assume things because you can't actually see them, right? So this therefore removes the study of origins from observational science and places it in the discipline of what's known as historical science. And the scientific method gets really fuzzy in the historical sciences. Why? Because you can't see anything, okay? Last time I illustrated this problem by considering how one might walk into a room and find that there's a candle burning. And the question comes up, how long has the candle been burning? How can you tell how long it's been burning? Well, we found out that strictly using whatever observations we might be able to make of that particular candle in that particular room, in the present, as we are there, whatever we use doing that, we will never be able to draw any certain conclusions about the question of how long the candle's been burning. Why? Because we have no idea what the conditions were before we came into the room. The rate at which the candle burned down before we arrived cannot be determined. If a slight breeze went through the room, if someone opened a window in the room, or they left a door open, let's say, or they turned on a fan and it stirred up extra oxygen getting to that flame and speeding up that burning and thus speeding up the rate of burning, well, we'd never know about that because we weren't there to see it. If there were faults within the candle itself, such as perhaps bubbles in the wax, let's say, air pockets there, that when it didn't actually form well when they were making it, that would much more rapidly decrease the size of the candle as it burned. Well, if that would speed up the process, well, we wouldn't be able to know about that because all the evidence for it would be destroyed as the wax melted into nothing. We'd have no clue about the bubble there. In fact, we have no real idea of how tall the candle was before it began to burn. That was a major problem that we talked about. How tall is it? Is it 7 inches, 9 inches, 13? We don't know. We weren't there to see it before it began to burn. And by the way, for the purposes of our illustration, it is not fair to use additional candles in our experiments in order to form a broader database to which we can then compare our candle in question. You can't go out and say, well, we burned 20 similar-looking candles, and the average rate of burning is this, and so we figure it's been burning for, you can't do that. And why? Well, after all, there was only one origin of life event. There was only one origin of the earth event. There was only one origin of the universe event. We have no other observable origins of life, origins of earth, origins of a universe to which we can compare our own. All right, there's nothing there that we can observe and then compare it to our own. We only get one universe. We only get one earth and one origin of life event. So we only get one candle in our experiment. All right, we're only able to try and figure out the time frame for the burning of that single candle from that single candle itself. We have nothing else to which we can fairly draw upon to make the analogy stick to what we're really talking about. All of this tells us we can only speculate on how long the candle's been burning. And to do that, we must make some assumptions. We may assume that the candle has always burned at the same rate at which we presently observe it to be burning. We have no way of verifying that, however. We must also assume how tall the candle was when it began to burn, and we have no clear way of verifying that either. We must further assume that no outside force, no outside process interfered with or acted upon either the height of the candle. Suppose I took a pair of scissors and cut it and then relit it, we just lost about 3 inches or something. We have no way of, we could not have any other force like that acting on the height of the candle or the rate of the burning. And again, we have no way of knowing whether either of those things or both of them or whatever ever happened. In short, for any process which we are unable to have observed, we must assume how much material was present at the beginning. We must assume how fast it has been changing over time, and we must assume nothing acted on either the material present or the rate of change, that there was no interference with our candle there to mess up. And that's a lot of assuming just to figure out how long a candle has been burning. And it's because of this that the father of modern geology, whom we talked about the last time, the 19th century lawyer Charles Lyell, this is why he had to say that the present is the key to the past. If he's adopted an atheistic, essentially atheistic view of how things began, that there is no God involved, and he has to conclude that they came up, things arose by themselves somehow, which is really all you're left with if you rule out any kind of agent of any kind to bring that about. You rule all that out. Then the only thing he's left with is, well, what we can see in the present must therefore be the key to the past. He tried to put a positive spin on it with that. The present is the key to the past. And that sounds real positive, but really that's admitting that that's Lyell's only shot at explaining what happened in the past. The only thing we have is what's right before us. We have nothing else. It's the same as the burning candle in the room puzzle. He basically says here, we must assume that what happened in the past is essentially what we see happening today. And when you put it that way, it's not quite as positive. But because of this statement and his whole idea of uniformitarianism, he becomes the father of modern geology. It means that what we observe happening today has always happened at the same slow rate throughout the whole long ages of history past. That's uniformitarianism. A uniformity. Has to be a certain uniformity to the processes observed today. They must have always acted like this. We have no reason to think otherwise. That would be his argument. Lyell was the guy that we talked about last time, who was trying to do away with what he called the Mosaic, capital M, system of geology. Not mosaic in a whole bunch of stones lying in a nice little pattern that looks like a donkey or something. No, the Mosaic with a capital M. He's talking about Moses. In other words, he wanted to reject the writings of Moses as found in the book of Genesis. He wanted to do away with the creation account. He wanted to do away with the flood account, which a universal global flood would have a major impact on geological forces. And he didn't want to do that because he just doesn't want the Bible involved, okay? He wanted God out of the picture. And he says there, I conceived the idea 5 or 6 years ago that if ever the Mosaic geology could be set down or put aside without giving offense. In other words, we don't want to offend these religious people, but we want to be able to lay this aside because it's a stickler for what we want to do. It's messing things up for us. And he said that in a letter to a friend, and that's how we know he was opposed to the Bible as much as he was. In order to be able to put that all aside, he had to assume, and again, this is a huge assumption, that what we see in the present has always happened at the same slow pace. And here's the interesting thing about Lyell. He thought that by doing this, he was doing away with the Bible, but instead, what we read in the Bible is that in the last days, Lyell and others like him would show up. It was prophesied in the book of 2 Peter. They would show up on the scene, Peter says, these scoffers, scoffing at the Bible and dismissing the creation account and the account of the universal flood in particular, the Mosaic system, according to Lyell, right? 2 Peter 3, verses 3 through 6 lays this out. Above all, Peter says, you must understand that in the last days scoffers will come, scoffing and following their own evil desires. They will say, where is this coming he promised? Talking about, you say Jesus is coming back. Where is he? He hasn't come. Where is he? look at this now, ever since our ancestors died, everything goes on as it has since the beginning of creation. That, friends, is uniformitarianism right there in a sentence. The present is the key to the past. Things have always happened in the past the way we see them today. It's exactly what that says. Everything goes on as it has since the beginning of creation. He gets credit to be the father of modern geology because he says the present is the key to the past. Well, 2,000 years before he was on the scene, the Bible already said that. It said there were people who were going to show up in the last days and say this kind of thing. And here he is. He showed up. But, verse 5 says, they deliberately forget that long ago, by God's word, the heavens came into being, and the earth was formed out of the water and by water. And verse 6, by these waters also, the world of that time was deluged and destroyed. So the very things that he wanted to get rid of, the creation and the flood from the Mosaic story in Genesis, actually it was told and foretold 2,000 years before that's the very thing that they ignore. They deliberately forget. They are dumb on purpose. I've heard it explained. We're not supposed to say they're difficult on purpose. There's a whole story about that with our granddaughter who was said we could not use her mother said we could not use the word stupid or dumb, and so our granddaughter came up at 4 years of age with her own substitute word, and the word was difficult. And that's a whole other story. It was quite fun to hear her come up with this. But take a look at this. God told us that guys like Charles Lyell, difficult guys, were going to show up in the last days. Therefore, we shouldn't be surprised to discover that those folks are here today, and that they're saying exactly what the Bible 2,000 years ago said they would be saying. That blows my mind when I think about that. Of course, there is a question here, and it's an important question, which this discussion about the age of the earth brings to mind in a more modern setting. But what about carbon dating? I've been told that carbon dating proves the earth is millions of years old. Okay, so we have this question come up. So right, maybe the people in the 18th and 19th centuries could only speculate. They could only assume about such matters. They didn't have the wherewithal and the advantages of scientific procedure we have today. Today we have these testing procedures like radiometric dating, which can scientifically prove the Earth is old. We have a radioactive isotope, and we can measure the rate of its decay, and that can tell us by looking at things how old this rock is or whatever. Well, what we have talked about so far, uniformitarian geology, the geologic timescale, index fossils, all of that was pretty much established back in the 19th century. At least the foundations were laid for it. It's been refined. It's obviously been changed over time as more fossils have been found and more speculation has been done, more observations of present-day conditions have been made, and much more speculation has been done over the last 200 years. But the basics of this were all established over 150 years ago. Okay. Dr. Willard Libby and some colleagues who were working with him at the University of Chicago developed radiocarbon dating, or carbon-14 dating, back in 1949. And Libby received a Nobel Prize for his work on radiocarbon dating. Remember, the Earth was assumed to be very old. That was true in 1949, even as it was true in Lyell's day, even as it is true today. The Earth assumed to be very old. All right. The new radiometric techniques that were about to arise in the mid-20th century were presumably going to tell us how old things actually are. In other words, they're not trying to prove that the Earth is old. They've already assumed that, and now we're just going to try to find out how old things actually are. So the idea that carbon dating proves the Earth is millions of years old, that is actually like some kind of weird urban legend. Okay, like alligators in the sewer of New York or something. It's virtually impossible to use the carbon 14 dating method to get dates of millions of years. But everybody thinks that or many people seem to think that that's true, that carbon 14 can tell you that. For starters, carbon dating is only used on things that were once alive, things that had carbon in them, like plants and animals and people. No rocks or any non-living matter can be dated using carbon 14, C14. You have to have carbon in there in order to measure for carbon 14. Secondly, the whole carbon dating process is dependent upon the half-life of the C14 atom. And the half-life for the carbon-14 atom is 5,730 years. So what's a half-life? All right. Well, basically, you see, as with all radiometric dating, you have to have a radioactive isotope, an element that is getting rid of material. It's kicking off matter. Think of a Geiger counter that clicks every time some particle hits the plate inside, and it makes that static clicking that you hear, as we have uranium there or something like that. All right, then there's other lesser radioactive things, such as carbon-14, which are also kicking off particles. Carbon-14 is basically unstable, so it's losing particles at a regular pace. It's trying to settle down, all right, trying to stabilize, and it needs to throw off these particles in order to do that. It's too unstable the way that it is. It's radioactive, essentially. And the half-life of a radioactive element is how long it takes for half of a given quantity of that element to stabilize. For C14, carbon-14, that half-life number is 5,730 years, the top number on the chart there. One half-life is 5,730 years. For example, if you have 2 pounds, let's say, of carbon-14, theoretically, in 5,730 years, you're going to have only half of that. See, it says 1/2 is left. That would be a pound, right? And then in 2 half-lives, 11,460 years, you're going to have 1/4 of a pound. All right, 3 half-lives, 17,190 years, 1/8 of a pound left, and so on and so forth. It's just going to keep. That's not the way I set it up. If I set it up as a pound, we'd have 1/2 a pound left after 5,730 years, and then 1/4 of a pound, then 1/8 of a pound, then 1/16 of a pound, and you get the idea. Okay, of carbon-14. All right. Thus, carbon-14 dating is really only good for a few thousand years, if it's any good at all, which is questionable for reasons we'll look into in a moment. But there's this idea, see, of it being for millions of years, and it's just not, okay? Remember, we were at when we were doing homeschooling with the kids, we went to Luray Caverns, and we were taking a tour, and the tour guide, young man, was telling us all about the rocks and everything, and the Luray Caverns are beautiful, and he talked about the stalactites and how old they were. How do they know how old they are? Well, carbon dating tells us stuff like that. They use things like carbon dating to tell us. And I said, well, wait a minute. I said, carbon dating does not test for millions of years. You're saying these things are millions of years old. Carbon dating doesn't do that, Okay, and he got kind of a smirk on his face, like, but my point basically is, if you're going to tell people something, make sure you're telling them something that's true. There probably aren't alligators in the sewer of New York. Hate to disappoint you, but it's probably not that way. Anyway, in reality, as far as C14, carbon-14, in reality, there are only about 10 pounds of carbon-14 in our atmosphere at any given point in time. So there's never really very much carbon-14 around on the whole Earth. 10 pounds spread out over the whole Earth. Think about how little that actually becomes. Not very much of it there. Carbon-14 is actually created in the upper atmosphere. When cosmic radiation bombards the atoms that are up there in the atmosphere, and it knocks out some free-ranging, energetic neutrons. You can see the neutrons there. They're blue. I don't know if they're really blue in life, but in the chart we got blue ones, and they're bouncing around up there kind of on their own, and they're looking for a home. And a neutron collides with a nitrogen atom, which you see there, and it converts it to a carbon-14 atom because the nitrogen atom picks up a couple of extra an extra neutron into its nucleus, and it kicks out a proton and creates hydrogen as a byproduct of that whole process. But now the nitrogen is like a heavy carbon. It's got an extra neutron, and that changes what kind of element it is. And so now it's a carbon atom, but it's a heavy carbon. Carbon-12 is kind of your normal carbon. This is carbon-14. But carbon-14 is going to act like carbon. It's not going to act like nitrogen. It will bond with oxygen, okay? Just like standard carbon-12 would do. And 2 molecules of oxygen will bond with 1 molecule of carbon and form our close friend carbon dioxide. Okay, and so we have carbon dioxide there with carbon-14 in it. A lot of carbon-12, little bit of carbon-14. Plants take in the carbon dioxide, so plants also absorb a certain very minuscule but yet measurable amount of carbon-14. Animals eat the plants, and also animals eat other animals. You got the goat there eating the grass. If we had a lion showed up, he might eat or a T-Rex, depending on where you're at. He might eat the goat, and he would get the carbon-14 that's in the goat into his system. So all living things take this in while they're alive. They have a certain amount of carbon-14. Okay, but when a plant or an animal dies, you can see in the soil there we have the logs buried for the tree, and we got the bones of the horse. In this case, it obviously stops taking in carbon-14 because it died. Here we can see the cosmic radiation coming in from the sun in the upper atmosphere, hitting the nitrogen-14, and it kicks off the hydrogen atom there. Neutron is captured, becomes carbon-14, and that kind of explains it a little bit more detail, so I just had that there. Beta decay, right? And now it's going to decay. So it obviously stops taking in carbon-14 when it dies, this horse, okay, or whatever it is, the tree, they stop taking it in. The theory, therefore, is this. Since the carbon-14 rate of decay is known, the half-life, 5,730 years, it is possible to determine how long ago something died by measuring how much carbon-14 is still left in the remains. This is basically our candle experiment, okay? We can look at the candle and we can figure out, because we know some certain things that are true, or they are assumed to be true, all right? Like we assume that the candle was 7 inches tall when it started. We know how much material was there when the whole process began, when the thing died. And so supposedly all living things have a certain fixed amount of carbon-14 in them, just like the candle we supposedly is 7 inches tall if we decide that's what it was. You can figure out how much has been lost then since the thing died. Now it's only 2 inches. We lost 5 inches of the candle. In this case, we have lost a certain amount of carbon-14 in a certain amount of time. By testing to see how much is there, we know how much has been lost. That's the idea. Okay. Recall I said there isn't very much carbon-14 around in the first place, even in living things. So there's even less in dead things, and eventually you get to the point where there isn't enough carbon-14 to detect or measure in the sample. Some say carbon-14 can't be used to date anything more than about 10,000 years. Most people today, most people that are into this, might set a limit of around 50,000. But it doesn't get into millions, okay? It can't do anything with millions of years. Anyone who tells you that carbon-14 dating proves that things are millions of years old doesn't know what he or she is talking about. Besides all this, carbon dating, though it sounds very scientific, is actually still dependent on some pretty significant assumptions. The assumption is that the rate or the amount of carbon-14 in the atmosphere at any given time has been the same for a long time, for millions of years actually is what they say. And so we know what the amount of carbon-14 this horse had in it when it died. All right. In the same way, assumptions led 19th century thinkers to assume great ages for the Earth and the universe, as we saw last time. So folks working with carbon-14 dating today have to assume, for example, that living things have always had the same level of carbon-14 in them. In other words, the question becomes, has the level of carbon-14 always been the same in the past when we weren't there to observe it? We weren't in the room yet to see the candle burning, right? We hadn't gotten there yet, so we can't observe it. You can kind of see from this, if you look up there around the sun in the upper left corner, it says a much stronger magnetic field in the past blocked a lot of the cosmic radiation, or it would have done that. And the interesting thing is the magnetic field is known to be decaying. Okay, it's decaying at a certain rate, and if you take that and you extrapolate it backward, you can say that several thousand years ago, the magnetic field was much stronger than it is today. So that's going to affect your carbon-14 formation in the upper atmosphere, because it's blocking some of that radiation that now we get because the magnetic field is less, okay, than what it was, less strong than what it was at one time. So that's going to impact your numbers. It's going to make things look older than they actually are. All right. See, this is all based on the same uniformitarian assumptions that Charles Lyell came up with. We assume things that we see in the present are the same all the way back. What we see happening in the present has always been the same in the past, and that's essentially what's being said about the C14 here. For millions of years, it's been this way. Because the Earth is so old, okay, it's assumed that carbon-14 production has by now reached a state of equilibrium. Equilibrium is best represented by a bucket with holes in it. If I can get water to flow to the bucket from the spigot at the same rate that water is leaking out the holes in the bucket, I can say that the water level in the bucket has reached a stage of equilibrium. The water level is not going to change. It will remain at that same height because the same amount's coming in as is going out. See, that's what's assumed basically in carbon-14 dating. The rate of carbon-14 production and loss, has been the same for millions of years now, and so we know that this dinosaur or whatever we're dating. Well, they wouldn't date a dinosaur because, well, we'll get to that. But this particular thing from 10,000, a mammoth. Let's just say a mammoth, okay, from about 12,000 to 20,000 years ago. We can date that with carbon-14 because we know how much carbon-14 the mammoth was taking in, except we assume how much carbon-14 the mammoth was taking in when it was alive. All right, it's probably been fairly constant, the C14 level, for a couple thousand years at least. So carbon-14 is a useful tool to a point, but the further back you go, see, in time, the less accurate it is. And that's because of things that are happening that we just weren't there to see. And that includes the magnetic field and that kind of thing. In fact, carbon-14 can get kind of weird, because there's some things that are thought to be so old, like dinosaurs, that carbon-14 shouldn't even be in them at all. And yet, carbon-14 has been found anyway. if we take a look at that chart there, and what I'm going to do here for a quick moment is open something else up that I need to look at so I can see that picture a little bit better. Let me see here. Give me just a moment or two or five or something. It's going to take a lot longer time than we thought. See, the carbon-14 is... let's see. Here we go. And we get down to our slide here. There we go. Okay. And let's run that from the current slide. There we go. Okay. Now, if you look on that chart, it says carbon-14 in dinosaur bones. There's not supposed to be any. Dinosaurs died out 65 million years ago. Many of them lived like 225 million years ago, according to the way they describe things and the ages they have for everything. There shouldn't be any carbon-14 in there because it's only got a half-life up to, they say, about 50,000 years, and then it's done, you know. Well, not the half-life is 5,000, but you only go back about 10 times, 10 half-lives or so, and you're done. Okay, now look at the sixth thing down on the list there, that Allosaurus. Okay, and if you go out across from there to this carbon-14 that was found in this Allosaurus, all the way at the end, we see that it came from the state of Colorado. All right, the remains. They tested the bones. They found carbon-14. The carbon-14 date that they got was 31,360 years, plus or minus 100 years. All right, so that does not square at all with what we're told about how old dinosaurs are. And yet this is the result of carbon-14 dating. Something's not right. If this is, and you can see other examples of other dinosaurs there, several hadrosaurs, 3 of them it looks like, several triceratops, an apatosaur, and I think the list goes on from there. And they're all found in the United States, out in the West, Texas, Colorado, Alaska, Montana. These remains are tested. They all had carbon-14 in them. And they all tested to no more than 40,000 years old. That can't be right if dinosaurs really lived millions of years ago. So you can see where this problem comes in when it has these dates. The Institute for Creation Research, these guys are fully trained scientists, just like they've studied at the same universities that others in their field have studied at. They have the same. They had to earn their degree just like anybody else. They had to do. They've done papers. They've published all these kinds of things in their fields, and they are respected scientists. It's just they believe in creation. And they have not done the Lyell thing and gotten rid of the Mosaic system, okay? The assumptions are different. That's the only difference between them and the other scientists. They did a project at the Institute for Creation Research called Radioisotopes and the Age of the Earth, or RATE, R-A-T-E. A good report on what they found out is in a book for lay people. The book shown there is really highly technical. I've got a copy of the volume 1, and I read the first few pages, and I found it interesting, but I also found it taxing on my brain, okay? But I also have Don DeYoung's book, Thousands, Not Billions. And he writes in his book, Thousands, Not Billions, about carbon-14 dating. He says several creation scientists have previously explored carbon-14 dating, including Melvin Cook, Robert Whitelaw, Robert H. Brown, and John Woodmaret. Also, Paul GM, I guess, conducted an extensive survey of the radiocarbon literature from the 1980s and 1990s. And he found more than 70 published reports of significant amounts of carbon-14 detected in ancient, quote-unquote, organic samples, things that are supposed to be old, but the carbon-14's there and it shouldn't be. A further rate review, he says, of the radiocarbon literature found many additional examples. All right, these include carbon-14 in fossils, in petrified wood, which is supposedly millions of years old, shells, whalebone, coal, which is millions of years old, oil, and natural gas. The resident carbon-14 content is also found in inorganic rocks and minerals, including marble, graphite, and calcite. These samples come from all around the world and from all depths in the soil. The detected carbon-14 atoms simply should not exist in these ancient materials, and yet here they are. All right. To understand the significance of this carbon-14 finding, consider a comparison. Suppose an archaeologist investigates an Egyptian mummy. The outer covering is carefully removed to reveal the ancient, undisturbed interior. As the last wrapping is removed, an amazing discovery is made. Inside the mummy is a wind-up clock which is still ticking. Must have been a Timex, right? Perhaps the mummy is not as old as the archaeologist initially thought. That clock in there tells a different story. The discovery of carbon-14 in supposedly ancient samples is just as startling to the conventional radioisotope dating community. These things should not be found. This carbon-14 should not be there, but there it is. Some of the most convincing evidence to me personally was learning that the RATE team had diamonds tested for carbon-14. Diamonds. Diamonds are made of carbon, so they were once living matter, likely plants or trees that was changed and crystallized under extreme pressure and temperature. Diamonds are strongly related chemically to coal in their structure. So that's coal in the background there. So that's why the two are together. But natural diamonds are considered to be so old. Wikipedia says between 1 billion with a B and 3.5 billion years old. 3.5 billion is nearly as old as the estimated age of the Earth itself. They should have no carbon-14 in them at all. Yet when the RATE scientists sent several diamond samples to several different labs which do the carbon-14 dating, understand the scientists themselves didn't do it. They sent it to labs that do that regularly, commercially. They do carbon-14 dating. All of the samples of the diamonds, every one, came back with carbon-14. And there were several different labs doing the work. Diamonds, folks, are the hardest minerals we know, the hardest thing on Earth. The surface of a diamond, well, the whole material of a diamond, really, but it is virtually impermeable. There's no chance that these samples could have been contaminated with C14, especially with that many samples, that many different control labs, and so forth. There's no chance that carbon-14 somehow leached or was carried by water into the diamonds to permeate the surface, to contaminate the samples used for these tests. There's no way you're going to get carbon-14 in there. But the carbon-14 was there. The assumption is, therefore, it was a natural product in the diamond itself from when it was alive and not something that came in later. This tells us that there's either something wrong with radiometric dating methods, so we shouldn't trust them, or things aren't nearly as old as we have been told. As Goofy would say, there's something wrong here. Looking at all this combined, all the guesses about how old the Earth is, using present observations to figure out what happened in the unobservable past, fossils dating the rocks, but the rocks dating the fossils better, that whole circular reasoning problem, and difficulties with radiometric dating like C14 found in diamonds and in dinosaurs, we can see that the concept of the vast age of the Earth is based upon imagined ideas, unprovable assumptions, and circular reasoning. It's the same now as it was in the 19th century at the core. There's nothing scientific about it. So it wasn't science or the scientific method that suggested that the earth was millions of years old. It was a philosophically driven movement to get away from the Bible. Lyell said that. And the present-day scientific and academic communities believe in the essential doctrines of this philosophical idea, even when those doctrines and beliefs run counter to common sense. Richard Lewontin is an American evolutionary biologist, mathematician, geneticist, and social commentator. He is presently listed on the Advisory Council of the National Center for Science Education. Not surprisingly, he is an atheist. Writing in a 1997 review of one of Carl Sagan's books, which was entitled The Demon-Haunted World, Science as a Candle in the Dark. In other words, science dispels the notions of the supernatural. That's in the title. And remember, Carl Sagan was the one who said, the cosmos is all that is, all that ever was, and all that ever will be. Okay, we talked about that last time. Lewontin said the following in his review of this book. Take careful note of what he is saying here. He says, our willingness to accept scientific claims that are against common sense is the key to an understanding of the real struggle between science and the supernatural. We take the side of science in spite of the patent absurdity of some of its constructs, in spite of its failure to fulfill many of its extravagant promises of health in life. Follow the science. Anyway, in spite of the tolerance of the scientific community for unsubstantiated just-so stories. Why? Because we have a prior commitment. A commitment to materialism. And that is the foundation stone for this, he's calling it science, I wouldn't, scientific attitude. A commitment to materialism. Folks, materialism is not science, okay? It is a philosophical belief system, all right? That the material world is all that is, all that ever was, all that ever will be. The same as Carl Sagan's quote that we looked at last time. All right? It's a philosophical belief system. It's not science. It cannot be scientifically proved. They have no way of demonstrating that materialism or material matter is all that ever has been. They have no way of showing that. He goes on to say, it's not that the methods and institutions of science somehow compel us to accept a material explanation of the phenomenal world. Okay, so science itself doesn't prove this, okay, to us, but on the contrary, that we are forced by our a priori adherence to material causes. Means prior assumptions that they make and hold before they run their test and before they draw their conclusions. They do this a priori adherence to material causes, to create an apparatus of investigation and a set of concepts that produce material explanations, no matter how counterintuitive, no matter how mystifying to the uninitiated, to the unconverted, right, to the ones who are not disciples of the belief system. Moreover, he says that materialism is absolute, for we cannot allow a divine foot in the door. God is not allowed, okay? The eminent Kant scholar, Louis Beck, used to say that anyone who could believe in God could believe in anything. To appeal to an omnipotent deity is to allow that at any moment the regularities of nature may be ruptured, that miracles may happen. He wants to get rid of God even more so than what Charles Lyell did 150 or so years ago. God is not allowed in the laboratory, not because science says he can't be there, but because the belief system of philosophical materialism says that he can't come in. Note that Lewontin cannot allow himself to believe in miracles because he says they rupture the regularities of nature, which is the very definition, it's a good definition of miracles. It's something that is supernatural, beyond nature, that is happening. And he's saying that can't happen. He's saying that dedicated scientists must also be dedicated materialists, and I don't believe that. All right? They don't have to be. Please note, friend, most of the founding scientists, by the way, in our scientific world, were Christians who believed in God and were actually looking at how God had done his creative work and what he actually made, which is marvelous when you begin to look into the design and the evidence for his fingerprints are all over everything, as he's obviously there. Anyway, please note, friends, it's a matter of belief and faith with Lewontin. Okay, when he says scientists have a prior commitment, a commitment to materialism, he's using faith words there. They've made a commitment. Just like we might say we have a commitment to Christ. We have a commitment to believe the Bible. He could no more prove as absolutely true the tenets of materialism that I could prove God's existence by having him come into the laboratory and perform his miracles at my command. Okay? I appreciate Dr. Lewontin's honesty about what he believes. We need something like that. This reminds us that this debate about origins is not between science and the Bible or some such nonsensical characterization. It is the clash of two worldviews, two belief systems. Some believe, as the Bible describes it in 2 Peter 3, that all things continue as they have been since the beginning. No involvement from God, no divine foot in the door. Where's the promise of his coming? He's not allowed in anyway. Okay? Others of us choose to believe that the Bible is the very Word of God. What God says about what he did when he created everything, it matters to him. And folks, anything that matters to God ought to matter to us. See you all next week.